Okay, so we're looking at exponents today, and we're going to start by looking at bases, exponents, and powers. So what are exponents and what do they mean and why do we use them? So when a factor is being repeated several times, so in this example, one sec. Okay, so in this example, we have 5 times 5 times 5 times 5 times 5 times 5. So there's 6 5s being multiplied with each other. So therefore, we can write that as 5 with an exponent of 6. So you have to make sure that you write the 5, which is your base, as normal sized, and then the 6 is written as a superscript. So up in the top right corner, but in a smaller notation. And then this whole thing, 5 to the power, 5 with the exponent of 6, that's called the power. In the video I'll show, you will see that people started mixing up the use of exponent and power, but it does mean the same thing here. So here's another example. Instead of writing 3 times 3 times 3 times 3, we can write it like this, 3 with an exponent of 4. So the 3 again is called the base. Same thing here, the 5 was the base. The exponent in this case is 4. In this case, the exponent was 6. And then 3 with the exponent of 4 is called the power. And here, 5 with the exponent of 6 is called the power. So if we look here, again, exponents are used when a factor is repeated more than once. The exponent tells you how many times you write out the base to get it into its standard form. So if it's 4 is the base, 2 is the exponent, that means it's 4 times 4. That's the factored form. And then 16 would be the standard form because 4 times 4 is equal to 16. All right, so this is the exponential form. This would be the factored form, and this is its standard form. So here's another example. We have 7 with an exponent of 3. So 7 is the base, 3 is the exponent. So that means it's 7 times 7 times 7. That's its factored form. And if you multiply that out, 7 times 7 times 7, that gives us an answer of 343. So that's our standard form. All right, a common mistake students make is they'll just multiply 4 times 2. That's not correct. That'll give us an answer of 8. It's actually 4 times 4. Same thing with here. Students will multiply 7 times 3. Remember, if it's written as an exponent like this, top right, in a smaller notation, that's the exponent. That means the base is being multiplied that many times. So let's look at this chart here. So we have exponential form, and then we have it written in word form. So here you can say 7 to the 3rd power. Anytime you see 2, that means it's squared. So you can say 4 squared. Anytime you see a 3, you can also say cubed. So 7 cubed, this is 4 squared, this is 2 to the 5th power. This one's an important one. Anytime we have an exponent of 0, the whole thing just becomes 1. So 6 to the power of 0 is just equal to 1. So here we've written it into factored form. So 7 to the power of 3, it's 7 times 7 times 7, which is equal to 343, and so on. 2 to the power of 5, that's 2 times 2 times 2 times 2 times 2. We've written it out 5 times, and that gives an answer of 32. It can also be a fraction can be given as its base. So here we have half, so half times half times half, which gives 1 over 8. All right, and then just a note at the bottom here, 7 to the power of 2 can be read as 7 squared. 5 to the power of 3 can be read as 5 cubed. So those are different ways we can write those. All right, on your calculator. So if you guys have your calculators with you, take a look at it right now. You'll find this button with the little top hat type looking button. You can use that button for calculating powers. You also will have an x squared button shown here. That's just to square buttons. That's just to square numbers. All right, so if you were doing like 5 squared, which is 5 times 5, which is 25. You can also use this button here that I'm talking about. It's a little triangle button. You can use that. So you'd put in your base. So let's say your base was 5 to the power of 4. You'd type in your base. Then you would type in that button. And then you'd put your power of 4 and get your answer. So 5 to the power of 4, which is equal to 625. Okay, that's 5 times 5 times 5 times 5. You might have a different type of calculator, and you might have this button. It's shown as y with an exponent of x. So you can use that button similarly for exponents. Okay, so next in this example, you just have to circle the base. So make sure you know which one is the base. The base is this number here. So here, the 7 is the base, the 2 is the exponent, 8 is the base, 10 is the base, 3 over 8 is the base, 1.63 is the base, 87 is the base. All right, know which one your exponent is for part B. Just circle the exponent. That's the exponent. 2, 3 is the exponent, the 5, the 4, the 2, and the 25. All right, here, fill in the missing factors. If it's 6 squared, we know that it is 6 times 6. Okay, fill in the missing factors. It's 2 times 2 times 2 times 2 times 2. That's 1, 2, 3, 4, 5 2's. Our base is 2, and our exponent is 5. All right, pretty straightforward there. Writing each in word form. We won't do all of these here, but we have 7 as the base. Our exponent is 5, so you can read it as 7 to the 5th power, or 7 to the exponent of 5, and so on. 3 to the power of 2, or 3 squared, 9 cubed, 9 to the 3rd power, and so on. All right, standard form. First one is already completed. So 5 squared, that's 5 times 5 is equal to 25. 7 to the power of 3, that's 7 times 7 times 7. I think we already did that. 343, and so on. Write each as a power. So 36, if we had to write that as a power, 6 to the power of 2, because 6 times 6 gives me 36. 49 would be another easy one here. 7 squared, because 7 times 7 gives me 49. All right, if we just have 7, it's not a perfect square, so that would just be 7 to the power of 1, which is just equal to 7. For 100, we just took a look at that. 10 to the power of 2, because 10 times 10 gives us 100. 25, that would be 5 squared, because 5 times 5 gives me 25. Anybody want to try 27? Okay, so we can write 27 as a power, because 3 times 3 times 3 will equal to 27. So therefore, 3 to the power of 3 is equal to 27. In these questions, B represents the base. What would the base be? So here, B would be equal to 6, because 6 squared is 36. Here, the base would be equal to 10. 10 times 10 will give me 100. Base with a 0, it equals to 1. Our exponent is 0, so base can be anything. So base can equal any number. I'll just put any number. Something to the power of 4 to give me 81. Here, the base would equal to 3, okay, because 3 to the power of 4 is equal to 81. When writing exponents, make sure you're very clearly writing the exponents up at the top corner. It just has to be smaller. Okay, and a base to the 5th exponent gives me 32. What do you guys think? What should the base be equal to? Try in your calculators. So in your calculators, if you type in 2 to the 5th power, that gives us 32. So the base is 2. All right, if you have an exponent of 1, it has to equal to 30. The base has to be 30. So here, the base has to equal to 30. 30 to the power of 1, which is equal to 30. So here, this would have to be 5 squared. Here, it'd be 3 to the power of 4. And here, it would have to be 7 to the power of 0 for it to be equal to 1. So in this example, we have the number 53,427. So we can use exponents to write this in expanded form. So we can say 5 is in the 10,000s position. So 5 times 10 to the power of 4 puts that in the 10,000s position. And then we have the 3 in the thousands position. So 3 times 10 to the power of 3 plus we have 4 in the hundreds position, so 4 times 10 to the power of 2 plus 2 in the tens position. That's 2 times 10 to the power of 1. And then we have 7 in the ones position, so that's 7 times 10 to the power of 0, which will put that into the ones position. This one, we have 4 in the 100,000s position, so that will put 4 times 10 to the power of 5. And then we don't have to include the 0, we'll just go to 7. 7 is in the thousands position, so 7 times 10 to the power of 3. Then we have 0 here in the hundreds position, 6 in the tens, so we'll just go straight to 6 times 10 to the power of 1. And then we have 3 in the ones position, so that would be 3 times 10 to the power of 0. So that's how we can use our exponents to write numbers in expanded form. Lastly is exponents and BEDMAS. So remember, for BEDMAS, B is brackets, E is exponents, then we have division, multiplication, which can be interchanged. Going left to right, and then we had addition, subtraction, which could be interchanged going left to right. But we do brackets first, exponents second. So if we look at some of these examples, let's calculate these using our BEDMAS rules. So 3 to the power of 3, if you put that into your calculator, that is 3 times 3 times 3, which is 27, minus 2 to the power of 4, which is 16, and that gives 11 as the answer. Okay, so trying the next one here, we'll work in the brackets first. So I'm just going to leave 6 squared like this. In the brackets, 2 to the power of 0, that becomes 1. 3 to the power of 1, that's just 3. So 1 plus 3. So we have 6 squared minus 1 plus 3, which is 4. 6 squared now is 6 times 6, which is 36. So 36 minus 4, which gives me my answer of 32. All right, let's try the last one here. 3 to the power of 4, so put that in your calculators. Gives you 81 times, we have 3 to the power of 3, that is 27. So now we have 81 times 27, which is equal to 2,187. Okay, I'm going to pause here. Let's just go over this one then. 6 squared, that's 36. And then in the bracket, 3 to the power of 3, that is 27. 7 to the power of 0 is 1. So let's just do that in the brackets. 27 plus 1 is 28. So we have 36 minus 28. That gives us our answer of 8. All right, so I'm going to pause here for today.